So as far as I can tell, there are only 5 main possibilities. We're either inside a closed universe, a self-contained one, infinite, directionally mixed, or disconnected, which would actually require the existence of the multiverse. And this is based on the fact that edge, and I mean any edge, can only connect to 4 things, which is that it can either connect to nothing, itself, something else. As for how that else, by the way, is different, I think it's teased in the name of the disconnected, again, we'll get to that, or it just doesn't exist. Now, most of them, and I'm just going to call them types from now on, have a lot of subtypes as well as important caveats, but we'll talk about them more when we get to them individually. Now, for us who did not guess from the title, we do not know the edge of the universe, nor do we actually know its exact shape. And we do have a concept of the observable universe, which is just what we can see, I mean, it's in the name. But the general scientific community, and I agree with the actual sentiment, doesn't really think that this is likely to be the edge of the universe. And the reason for that is a little complicated, but essentially it's just that we do not see any signs of any actual edges, and it's very, very unlikely to be exactly in the center of this sphere. I mean, it's obviously more complicated than that, but this is the easiest way I can actually explain this, without at least getting too deeply into the topic. So firstly, there's the infinite universe. Now, I'm not gonna spend much time talking about it because it has been talked at length in other videos, but basically the way this would work is that as you move into any direction, you would just encounter more space forever, and you can never get to its edge because it doesn't really exist. So as long as also the matter inside it will possess fair amount of possibility of its combinations, it will then be composed of endlessly repeatable patterns forever, which basically means that everything that can happen within it will happen an infinite number of times. But then again, I think you're kind of familiar with that because many other sources have already talked about it. Also, as far as I can tell, it has no cosmological subtypes or important caveats. The closed universe is when it actually gets interesting. So a closed universe is when the center point connects to either nothing or some kind of barrier, and by nothing I mean that the container space, as I call it, or so the very space itself just ends. And if you looked at it, as in the edge itself, you would just see nothing. Or technically speaking, you might be able to see something because light itself will be unable to proceed as well. It will get reflected to the sides, in which case I don't actually know what you would see. And the best way to think about it is that space is like seawater, and particles are like things floating inside it, while this nothingness is like the air. Or I guess some kind of stone, again, whatever you want to use as a metaphor. Now, the closed universe has a lot of subtypes, and these are further divided into 2 specific categories, and they are based on either the shape of the edge of the, and I mean the polar edge of the universe, as well as the composition of the edge itself, which can be either nothing, which we've talked about before, and it's just that the container space ends. It can be itself, some kind of barrier, or anti-space. Now, it's important to note here that these are mostly flavor differences with some exceptions. So as an example, itself might seem like it's a pretty substantial difference between that and everything else, because in other cases they connect to either nothing or some kind of barriers, and in this case they connect to itself. So it's like, well, you have something else versus you have itself. But in truth, this isn't like in self-contained universes. And instead, what I mean is that the very edge of the universe, so this very edge connects to this very edge. And this might sound kind of weird, and it is kind of weird, but what it basically means is that let's say you're some kind of particle and you move to the edge of the universe, and then you impact this edge of the universe. What basically happens is that this tip of the particle touches itself, as in like it impacts itself. And just like in the category of nothing, it pretty much leads to the edge of the universe being some kind of barrier. And speaking of barriers, and the barrier is also basically exactly the same, because the edge of the universe is in this case presumably some kind of spatial barrier. And the thing between these 3 is that you can't really tell the difference. Like, I guess you kind of can. Maybe using magnets. You see, if it's actually composed of itself, then perhaps the actual reflection of the field will be stronger, because in the case if it's composed of nothing, then, well, it would just presumably either stop or just scatter to the sides, and it's basically the only difference. They are basically to the same thing, which is that the edge of the universe is composed of some kind of unbreakable barrier, or I guess technically speaking, is it? Because you see, there's not much of a reason to assume that in the case of it being an actual like spatial barrier, that it would truly be unbreakable. Like, we don't have much of an indication or known laws of physics to say that, which means that if this was some kind of spatial barrier, then technically speaking, you could probably break it. But what would actually happen if you did manage to break it? I mean, maybe the universe would just be consumed by nothing. Who knows? I mean, like, it's fun to think about, but obviously it's something that presumably you wouldn't be able to write afterwards. Another possibility is that it would just lead to more space, but in that case, it isn't truly the edge of the universe. At least not the universe that I'm talking about, like the cosmological universe. It's more like the edge of some kind of enclosed pocket of space, and but again, that's not really what I'm talking about here. And the last is anti-space, which, to be honest, I don't really think it deserves its own category now. So the basic idea there was that either it's some kind of like end of the universe that just disintegrates space itself once you interact with it, which is kind of similar to just adding a different kind of a flavor to either a barrier or just nothingness. And the other was that we're basically in some kind of larger anti-space universe. So our pocket of space is inside a larger anti-space universe, but like, that's kind of the same problem that the spatial barrier had, that could lead to a larger universe. It's like, this isn't really the end of the cosmological universe that I'm talking about, it's more like a quasi-universe. And a quick note here is that the expansion of the universe doesn't disprove any of these flaws, since the universe can simply expand into either nothingness or with the actual barrier itself. And the final category is just the irregular versus regular, and this is more of a spectrum. I mean, and it refers basically to the shape of the, well, technically the edge of the universe, but in that also the shape of the universe itself, which is obviously shaped by the edge. And it can be really interesting. I mean, you tell me what you actually see, because I have no idea. Like, I don't know what that actually is. And by the way, the reason why I'm using 2D is because it's just easier for me to showcase this, and also like it's easier for me to create this. Like, I'm not going to spend so much time 3D modeling, just for like 5-second clip or something like that. And the best way to understand would be that these shapes exist in relation to the container space, so the base space itself. Nothing exists internally within them. They just, and by the way, the way I'm imagining them is that they're essentially like 3-dimensional, and they're essentially, so they are pockets of nothingness enclosed by something, so they're very containers to the space itself. And again, they don't actually, nothing is within them. They don't actually have any like spatial coordinates. They just, they only exist in relation to the space itself. Also, our universe probably wouldn't look like this, because, I mean, of course, unless some parts of it expand at much faster rates into this quote-unquote nothingness, but if not, then presumably you look more like a sphere or a cubicle or something like that, depending on what this original shape was. And if you think this is ugly, by the way, then believe me, we'll get to that actually ugly part soon. And the third type of universe is a self-contained one, and it's basically one where if you move to one side of it, you'll come out from the other side. So basically, its edges connect to each other. So if you move up, you'll come from down. If you move left, you will come from right, and so on and so on. Now, it has 2, 3, 4 subtypes. So it can be either perfect or, and yes, this is an actual type, ugly. And believe me, I have some even emotional reasons to think it's ugly. It's really ugly. And it can have real or unreal spatial gigantism, we'll get to that, which is arguably just another flavor difference though. Also, I don't know if it would work in its quote-unquote pure form, and we'll get to that more when we talk about the next type, section, whatever you want to call that. So, a perfect self-contained universe is one that is either a rectangular prism or a cube. A rectangular prism is just a rectangle, but 3-dimensional. In which case, unlike in some scientific projections, we will not see any contortions of space, like, for instance, spatial gigantism, we'll get that. And every edge will perfectly equal another, and you can see that in this admittedly, like, 2D model. But the same will happen in 3D, you'll just introduce, like, vertical lines. And as you can also see, if you zoomed out, it will create like this chess-like pattern of endlessly repeating squares, or like in 3D, like there will be cubes or again rectangular prisms, in which case they will get stacked on top of each other, again in every single possible direction, fitting without any need for spatial contortions as far as I can tell at the very least. And again, these repeating patterns are the exact same thing, so you would see yourself in every single one of them, again, endlessly, and again, it always seems to make sense with squares and rectangular prisms, which is why I'd say perfect self-contained universe. It requires no contortions. As for the ugly self-contained universe though, like, I don't even want to describe it. And this isn't just because it's ugly, it's also just very difficult to actually like explain this. So what you see on the screen right now is a 2-dimensional universe on top of a 3-dimensional sphere, and you can imagine it as kind of a globus. And it's a super simplified universe with only 5 points in 3 symmetrical directions, with these being the direction of X, Y, and Z. Now imagine you're in point O, and you look in all 360 degrees around you. For the sake of this thought experiment, you can. You would then see P as a kind of a ring with light flowing through all 3 points to O. And remember that 2D universe is one that has no up and down, and this fulfills this condition. And although in truth you can kind of argue this is really a fake 2D universe, because this is in truth a 3D universe that has a fake 2D universe stacked on top of it, but that's more of a framing. And the reason we're discussing this, by the way, is that something similar could be the case in our reality, with the obviously difference being that we're on top of a 4th-dimensional geometric figure. And I don't know if it's, by the way, possible, but I presume because in 2D we can have a fake 2D and a fake 1D universe. So I'm leaning towards saying yes, but so in 3D, just like here, the opposite point of the universe will be stretched in all directions, like again on a sphere. And yeah, I told you it's ugly. And everything around you, in fact, will be stretched the further it is from you, at least from your perspective, because again, the space itself will get stretched. And this is also why scientists speculate the universe has a minimum size, as we do not see these contortions. They just kind of assume a universe has to be ugly, or infinite. As for spatial gigantism, the idea there basically is that space can get like actually bigger, or it also narrows. So in real space gigantism, you have parts of space that are like literally bigger, And in Unreal, it just narrows down, which makes it seem like they are bigger because, again, the light spreads out and it will look kind of similar, but there are some differences in spatial coordinates. Although it is possible this might result in yet another type of the universe with an actual North and South Pole, in this case, like being the enlarged parts of the universe. But again, I'm not going to contemplate it here. Like, I'm not even sure this type is real, to be honest. I would have to like think about it more so. So the last two are fourth disconnected and fifth mixed. And I'll talk about them in kind of one segment, 1.5 segment really. And the note also here is that I don't think either of them are particularly likely to be a type of universe we're in. And I don't really have time to explain why, because this video is already getting too long. But also, we have little evidence to suggest that they are impossible. So we could be neither either of them. To be honest, I think they are the most interesting. But admittedly, they're kind of out there, you can say. So first thing, we'll start with the disconnected. So remember when I said an edge can connect to something else? This is basically what I meant. And you might ask though, like, but isn't this just an extension of a single universe? And this is a good point, but here's the catch. This isn't just a pocket of space inside a larger universe, as the large universe simply does not exist. And what I mean by that is that the universes it connects to, because this is what I meant when I said that it connects to something else, it connects to another universe. So what I meant essentially is that the universes it connects to change, and therefore there's no stable larger universe, especially if the ones they connect to also change. Now, this exists kind of in a gray zone between a cosmological universe type and simply a quasi-universe, they call them. It will really depend on the frequency of these disconnections, because let's say that they connect to once every 100 billion years. In that case, you can kind of argue they essentially form a different universes. They're essentially pockets of space inside the universe that can rearrange themselves, in that case creating a different universe from time to time. But if they connect, let's say, every other second, and the universes they connect to also change again, then you can probably argue that indeed they are just separate universes. And the way this will look like, by the way, is that let's say let's say our universe is kind of a cube, and now imagine that each side of this cube connects to a different universe. And from inside out, it will look like this, with each of these universes being a side of this cube. And also, they could be much bigger than our universe. And also remember that these two do not have to overlap. Like, think of them like basically portals. And again, these universes that you can see are essentially like, again, sides of this cube, but also they have portals to other universes. So this is what I meant disconnected. Another way this cosmological type could be a separate universe is by simply not making it a pure one. So when I talk about pure types, what I really meant is that they are types that are not mixed. So mixed essentially is, as the name suggests, it's the mixing of several types together. So again, remember that cube that we've talked about, a universe, or presuming a universe is a cube. So imagine now that only one side of this cube connects to a different universe, and all three other sides are, well, something else. So for instance, let's say that one side, the opposite side from the one that connects to a different universe, is infinite. And the other two are, well, actually the other four are self-contained. In which case, I think there's a good argument to be made that this indeed is basically a separate universe. I mean, only a tiny, infinitely small fraction of it actually connects to a different universe, kind of like a portal, basically. So even though it's a one side of it, in practice, again, it's so incredibly small that, and this, by the way, could be what our universe is. It's not a particularly likely option, even just because of how many other possibilities there are, but it is technically speaking possible. Again, we don't have much of an indication that it will be not. The only possible problem I see is that if a universe expanded at a much faster rate than the other universe, presuming it would even expand, it's possible that the side of the universe that connects to it will become bigger than the actual universe it connects to, which might cause some problems. But again, this is by no means enough to say that this would be impossible, as our reality presumably doesn't really playtest itself, first of all, and second of all, it would be a problem under only some specific scenarios, and thirdly, there would presumably be some specific laws or interactions that would actually happen if this did occur. And the shapes of these universes can get pretty wild. So this is one example that is from the side, and this is how it looks from the top. It's infinite in one direction, it connects to a different universe, it's self-contained in four of the other directions to its sides, and finally, it possesses this bizarre pillar of nothingness in its middle. Now, I wouldn't necessarily say that it's very likely or even remotely likely for a universe to be a combination of all four of these types, but it isn't technically impossible. It would just seem very bizarre thematically, if you can even say that in terms of explaining how why a universe exists. And again, the origin of a universe, presumably, whatever it is, would not result in something like this. Although, again, it's not impossible. We don't really know what the origin of the universe is after all, assuming there even is one, or at least in the way that we will be even able to understand.